This is the TriStar 900, and it is by far my favorite swimming pool pump. So let's talk about this pump for a minute and identify some of the reasons why I would say this pump above all other ones is my favorite. Before we can get started here, I need to say a couple of things. First of all, I need to say a special thank you to Hayward. Hayward has sent me this pump for testing in my test lab here. And that immediately introduces the idea that you're watching a video about my favorite pump, and it just so happens that they gave it to me. I need you to know they did not give me this pump, and that's why it's my favorite. That is not the case here. I have been talking about this pump for years. And if you follow me online or read my swimming pool blog on swimmingpoolsteve.com or watch any one of the 1,000 videos that I have on my Swimming Pool Steve YouTube channel, you will hear me talk about this pump all the time. So I'm going to talk about it here today, and I have free reign to say whatever I want, good or bad. There has been absolutely no money that has changed hands between I and Hayward. There has been no verbal or written agreement or even an implied agreement about here you have to make videos, or this is what we want you to say, or this is what we don't want you to say. There has been absolutely none of that. I can say whatever terrible things I want about. I can throw rotten fruit at this pump if I want to. Nobody can say or do anything about it. But I tell you what, you're probably not going to hear me say a lot of that because I really like this pump. Let me show you why. There are a lot of great swimming pool pumps in the market, so many to choose from depending on the kind of swimming pool you have, the type, the shape, the size, how demanding of a filtration system you need. So many to choose from. But I'm not here to talk to you about any of those pumps today. I'm not here to talk to you about Black& Decker or Pentair or even the Hayward Super Pump. Suck it, Super Pump. Nah, I'm just kidding, buddy. Here you go. I'm here today to talk to you about the Hayward Tristar VS 900. After 30 years in the swimming pool industry, I've learned a little bit about why people buy swimming pool pumps and what influences somebody to purchase one versus the other. And there's a number of these little features that I'm going to talk about with this pump here today, because these are the little things that actually inform you to make purchase decisions. And let me give you a great example here. This is the strainer basket that comes with the TriStar series variable speed pumps. And you might be thinking like, hey, that thing looks gigantic. And I would agree with you. Just as a comparison here, the most of the competing models available of swimming pool pump don't have strainer baskets that big. I mean, there's so many pumps on the market, but a lot of the more common makes and models that you might see, you're going to have something a lot smaller than this. Here's the strainer basket from the Hayward Super Pump. This one's from the Black& Decker series of pumps that are available online. It's actually pretty big, but still at least 33% smaller than the TriStar strainer basket. Here we have the Pentair Superflow strainer basket. And again, as you can see, the TriStar is like noticeably larger here. The size of the strainer basket is very important if you have a lot of trees around your pool, floating debris, things like that. During the worst times of year, you can be out there all the time cleaning out the strainer baskets because they get jammed up with leaves and that's no good for the pump. Having a larger strainer basket is absolutely a benefit. Like I'm not saying bigger is better. I'm just saying that larger is more good. Moving on. That's a great reason to buy a TriStar right there. Is if you have a lot of floating debris and a lot of trees around your pool, having a large strainer basket is a huge advantage for your pool pump. Since we've got this open, let's talk about the lid. This is one of those little things that makes a huge difference for people who are trying to choose a pump that's easy to work with. One hand, nice and easy. The large handles here, the coarse thread makes this a breeze to work with. And that's a lot better than I can say than for pretty much most of the pool pumps on the market. Some of them have slightly tricky lids that are a little bit harder. Some of them have very small knobs that you have to turn, and if you've got arthritis or weaker hands, you might struggle with that. It's a really common complaint. So the lid on this alone might be enough for somebody to buy this swimming pool pump in particular. The keypad interface on this pump rotates with 4 positions, 360 degrees, which is very convenient because not every pool pump installation is the same, and you don't want to have to be reading the screen upside down or sideways. So that's very convenient, and it's very easy to turn that with just 2 screws. You can replace it very easily. You can also elect to remotely mount this with a wire attached between the keypad and the base, and you can buy a cover for the where this open spot would be, where the controller would normally be. This pump is made for automation systems. If you have an automation system or you're planning a pool and you are planning that you're going to be including automation, you can get this pump. So is that it? Is that why I like this pump the most? Just because it's shiny and black and it reminds me vaguely of the Starship Enterprise? No, those are all secondary benefits here. Let's start talking about the stuff that I really like about this pump. First of all, you can see the connections here. They come with the pump. That's important because not all pumps come with union connections or any means to actually facilitate connecting the pipe to the pump. So it's nice that you don't have to buy anything additional. But there's more going on than just that. So let's talk about these for a second here. First of all, this is a union connection. There's a gasket on the front and top of the pump that when you tighten the union nut, that's it. You're not going to have any swimming pool leaks. And that's really convenient because a lot of the threaded connections that you have to make with a male adapter, they can end up leaking over time. And this is a really quality connection. You are not going to have a problem with a connection like this on this pump leaking over time. Further to that, you might notice the fitting is black, and that in of itself doesn't necessarily mean anything, but it is a CPVC union, not a regular PVC, CPVC. CPVC is heat rated PVC. That's very important when you're dealing with a swimming pool pump, which has the ability to generate large amounts of heat. If you had just regular PVC connection points, they could become misshapen when exposed to high heat for long periods of time, and then you can develop leaks. Again, with these CPVC union connectors that come with the Tristar pump, you are not going to have any problems with leaking, and that's one of the biggest benefits with these. But we're not done here yet. Let's talk about this just a little bit more. Here we see a comparison of the union that comes with the Tristar for connecting to the pump versus a threaded male adapter made out of PVC. Even the better option, which is a high temperature CPVC union male adapter, you can see, look at the size difference here. And this is super important when you're talking about flow dynamics. And there's a reason why this pump, this Tristar pump, comes with these really large fittings, but it is notable, I should say, to compared to some of the other major pumps that you might be considering purchasing, to see the difference between the connection sizes, and you can extrapolate from that how this is going to affect your hydraulic efficiency, maximum flow rates, things like that. Here's the union that comes on the Pentair Superflow pump, and it's sized for 1.5-inch pipe, or potentially 2-inch over the outside of that fitting. So you've got 1.5 and 2-inch as an option here. Not bad. Noticeably smaller than the Tristar. Here's the connectors that come with those Black & Decker pumps. And I want to show you something that's significant here. Both the Tristar and the Black & Decker have 2-inch slip ports that we could glue into here with 2-inch pipe. That's a good thing. With the Pentair Superflow, it's not quite as good, but we can sleeve a coupling over the outside to size up to 2-inch, which is also good. I love this feature. This is a 2.5-inch PVC coupling, and it fits right over the outside of the union that comes with your Tristar pump. This is extremely useful because, as I'll get into later, with swimming pool pumps, normally there's a lot of room for efficiency improvements. And I would say, probably 75% of you watching this right now have 2-inch plumbing for your pool system. It's pretty good. It's not bad. Could probably be a lot better if you had 2.5-inch, especially if you have any kind of bigger, fancier system with multiple section, multiple return lines. Probably there's a conversation to be had about having a larger sized system and being able to size up to 2.5-inch natively right in the pump unions. I love that feature. It looks like the Black & Decker ones would do it, but they don't. They're just 2-inch there. There are other ways to change between pipe sizes, but I really like this because I work with a lot of systems that end up using 2.5-inch pipe, so it's nice that we don't have to make any special considerations here. Since we're talking about pipe size, that kind of introduces the subject of the flow potential of this pump. And it's another one of the main reasons why I love this pump, and it's my favorite pump. It's only 1.85 horsepower. And you might be thinking, oh, well, I've got a 3 horsepower pump and that makes mine better, right? And that's definitely not the case. It is probably the number one thing that pool owners are doing wrong when they're shopping for a pool pump. You shop thinking bigger is better, and it's just simply not the case. For example, back before we had variable speed swimming pool pumps, if you made an honest effort to make an efficient swimming pool system in 1975, the size of the pump that you probably would have landed on would have been around 3/4 of a horsepower. Ideally, a high head 3/4 horsepower, that would have been a great choice. And I'm not talking for a little pool here. I'm talking for a 35,000 gallon 20 by 40 swimming pool. A 3/4 horsepower high head pump would have been able to deliver an impressive amount of water for a very small amount of energy consumption. And that small amount of energy consumption is everything. Swimming pool pumps have the ability to consume up to half of the power that your entire home uses in a month. And you might be thinking that sounds preposterous. That couldn't be the case. If you have an older single speed swimming pool pump and you run it around the clock, especially if it's a larger 2 or 3 horsepower model, yeah, that's actually the case. That's what you might be doing, and you might be experiencing outrageously high electricity bills because of that. When people shop for swimming pool pumps modernly, they want to see a big horsepower number on the label. And for decades, it's been the case that manufacturers of pumps use service factor ratings to make a smaller horsepower motor sound more impressive than it is. And it's very confusing because you would have two 1 horsepower pumps from competing brands, and one of them moves literally twice as much water as the other one. Also, it consumes more power. What the heck's going on? How does horsepower rating even work? You know what? It doesn't matter. I could explain it, but the reason it doesn't matter is finally the industry and pump manufacturers have moved away from horsepower ratings, which are deceiving by design, and we're now using WEF, weighted efficiency factor. And this is the new way in which you can measure the efficiency of one pump versus another pump in somewhat of an apples to apples comparison. You could look up more information on that. Something like this pump here is going to represent the upper echelon, or the very top in class, in terms of most efficient when it comes to the WEF ratings. So what's the point of all this about the size and the horsepower? And back in the day, we used to use small horsepower motors and we were lucky to have them. Well, the reason why I'm saying this is because at 1.85 horsepower, you might think, oh, it's not as good as 2. My neighbor Bob's got a 3 horsepower motor. Yeah, that's super common. There's even a big brother to this pump, which has a 3 horsepower close to it in size. But the thing is that it's too powerful for most swimming pool installations. And you might be thinking, well, I have a 3 horsepower pump and everything's fine. And I bet you if we were to examine your system, you are wasting a host of energy, which you could be saving if you reduce the size of the pump that you're using. Basically, short takeaway here, 1.85 horsepower sounds like a lower number to you. To me, the pump specialist, it sounds, wow, that's really, really powerful, but just low enough that I think this pump will be useful, because there's a lot of applications I can use this for where we're not going to be exceeding the maximum design flow rate of the filter or exceeding the maximum safe velocity of the suction line for your swimming pool. There's a bunch of considerations here that most people don't make when they're choosing a swimming pool pump. But I want you to know, that 1.85 horsepower is not a low number. It's a very high number, and let me explain why. Every swimming pool pump on the market has a performance chart available from the manufacturer. This shows you on one axis how many feet of head of resistance to flow versus how many gallons per minute the pump can move. So you don't have to guess. You can know exactly how much this moves. This pump moves a lot of water even against high resistance to flow, performing like a high head pump. That means if you have a system that has a lot of twists and turns, a lot of peripheral devices like heaters and other things where the water's got to travel through, and maybe a long distance to and from the pool. All of these things add head or add resistance to flow. To make an apples to apples comparison, look up the performance chart for this pump, the VS 900 from Hayward, and compare it to any other swimming pool pump you're looking at. Let's say you have a normal or medium-sized swimming pool. Let's estimate that at 30 feet of head. If you have kind of like a little bit busier, a little bit larger, let's call that 50. If you've got like a pretty advanced system, lots of plumbing, let's call that 60 feet of head. Take that comparison number between this pump and other comparables you're looking at, and what you're going to notice is that this pump moves an awful lot of water. Like in some cases, you might have been looking at a competitive brand. You compare this, even though it's, not that big of a number in terms of horsepower, but it might be double the flow rate of the other pump that you're looking at. Such is the nature of the design of this pump. Remember when I said back in the day, we used to use a 3/4 horsepower high head pump? We did that because it was efficient to do. And when you have a high head pump, it moves so much water, you don't need a huge amount of horsepower. So the fact that we have 1.85, that's a lot. 0.75, 0.75 is enough for a 20 by 40 swimming pool back in the day. We've got 1.85 horsepower variable speed power and a high head pump that moves a ton of water even at 50, 60, 80 feet of head. So it's a very versatile pump over a wide range of swimming pool systems. In a nutshell, versatility is probably the main reason why I recommend this pump more than any other pump. There's actually a ton of really good pumps in the market. There's a big brother to this one. There's tons of great stuff from other manufacturers, but this one just seems to fit on more pools. For the people that I help and I talk to and I consult with about swimming pools, more often than not, when I kind of get through the whole calculation, we come back to this one. So often it's this one, and it's the versatility, because you can use it on a really big pool with tons of suction lines and large ones at that. Or you could use it on medium-sized pools. You can use it on pretty small pools as well. So it's really got a lot of options here. It does have a lot of flow. You do have to be careful. You want to be sure that you're not exceeding the maximum flow rates for safety or for your other equipment like your filter. And a pump like this has the power to do that. And this is one of the reasons why it's very important to consider purchasing from a local pool and spa professional. Commonly these days we buy everything online. I definitely do that myself. This pump that we're looking at here is only available from your local pool or spa professional. You cannot buy this model of pump online. And one of the reasons why is because of things like safety. This pump moves a ton of water. If you were to put this onto a tiny little above ground swimming pool with a 1.25 inch suction line, you've just created a dangerous environment. And I mean, who spends the whole day in the pool? Your kids. So you just created a dangerous environment for your kids, and you didn't even realize it just by using this pump. It doesn't even sound like that much, 1.85 horsepower, but you would be wrong. This is a very, very powerful pump, and it needs to be sized appropriately for your system. You should speak with a local pool and spa professional, because that's where you can get this pump. You'll be covered for things like maximum warranty and support and things like that, and that's what I recommend that you do. When it comes to choosing the pump, the versatility of this one puts it on the short list for so many different pools, and I recommend that you shortlist this one as well if you're shopping for a new pump right now. Along those lines, if this video is helpful to you, this is the first time that Hayward's ever sent me something, and I've been making videos for years. In fact, just last week I passed 1,000 videos on the Swimming Pool Steve YouTube channel. Hayward sent me this pump. Here I am making this video. You're watching it right now. I mean, you could like and subscribe. It would take only moments. Maybe even leave a comment if you found this helpful. If you end up buying a pump, or this pump in particular, because of the information contained in this video, boy, I sure would love it if you left a comment down below. And it lets Hayward know that I'm doing a good job here, because you're going to buy the pump from them. I'm kind of just a person that doesn't need to be here in the middle, but it would help me a bunch to be able to be here to continue to make more videos like this. If this one goes really well, a lot of people leave comments, the YouTube algorithm will pick it up, a lot more people will see it, Hayward will give me the thumbs up, and maybe we'll see some more equipment from them that we can test out here. There's a ton of stuff in the Hayward lineup that I would love to get into my test lab here. Well, we've talked an awful lot about the pump. And that's a good thing because there's a lot of stuff to talk about here. But why don't we now take this thing, we'll bring it over to the test lab, install the pump. I can run it a little bit. I can show you some of the numbers behind how much water it moves, how little electricity it uses. These are all the things that make this such a great pump. So why don't we just go ahead and get started on that together right now? There are a couple numbers that I would like to talk about. First of all, in every swimming pool, there is a designated maximum for the amount of suction that you can have in any pipe, any suction line in a swimming pool. This is established by the VGBA, the Virginia Graham-Baker Act for Anti-Entrapment. And 6 feet per second of water velocity is the maximum that you should ever have in a suction line in a swimming pool. 6 feet per second in 1.5-inch PVC is about 38 gallons per minute. 2-inch PVC is about 65 gallons per minute. And 2.5-inch PVC is about 90 gallons per minute. If you have a swimming pool with one skimmer and you have 1.5-inch suction line and you have no other pipes at all for suction, then effectively your maximum should be 38 gallons per minute. Same thing with a 2-inch skimmer and a single 2-inch suction line. The maximum that you should ever be moving through your filtration system is 65 gallons per minute, based on the safety parameter of 6 feet per second, no more than 6 feet per second, water velocity for any suction line. So what if you had 2 skimmers or a skimmer and a main drain set or something like that? Well, now we can share the flow. If you had a 2-inch skimmer and you had a 2-inch main drain set, so you have 2 suction lines in use at all times for your filtration, well, then your maximum would go up to 130 gallons per minute total, assuming that you're sharing 65 each through each of the suction devices. So this is kind of how it starts when selecting a swimming pool and understanding flow rates and things like that. And this is part of the reason why I explain that this pump in particular, this VS 900 at 1.85 horsepower, 1.85 is not a small number. It's actually a very large number, and I'm going to show you a little bit more about that in just a second. For now, I want to also identify how 6 feet per second is the maximum water velocity for your suction line for safety. It also represents the maximum water velocity for laminar flow through your PVC plumbing system. Any water velocity in excess of 6 feet per second will result in efficiency loss. Not a little bit, a very drastic, exponentially rising efficiency loss as you go over and above this water velocity. This is very important. When you're talking about designing an efficient filtration system for your pool, what we want to do is create the optimal system. We want to save as much money as possible without, of course, sacrificing the swimming pool at all. With a 6 feet per second maximum water velocity in mind, as you can see with the numbers here, 38 gallons per minute for 1.5-inch pipe, 65 gallons per minute for 2-inch pipe, 90 gallons per minute for 2.5-inch pipe. We were talking about suction lines before, but now talking about the main trunk line through your filtration set. There's only one of them. What size do you have? It's going to be one of these 3 for 98% of you out there. And whatever size pipe you have through your filtration set, you're looking at the maximum recommended flow rate for efficient water flow, or most efficient water flow. If you had 1.5-inch plumbing, could you pump more than 38 gallons per minute? Sure, absolutely. I mean, 80 gallons per minute is really common for 1.5-inch plumbing. But the thing is that most of that is going to be very inefficient. 30 up into 38 gallons per minute, that's going to be very efficient flow. Everything above that, drastic efficiency losses from friction, turbulence, things like that. Same with 2-inch. 2-inch plumbing is what most of you likely have listening to this video. It is the most common for your filtration set trunk line for modern day swimming pools. So if you have a 2-inch system and you pump in excess of 65 gallons per minute, which most of you do, then it's not a problem, but this is an opportunity to change the way that you're filtering water and do it more efficiently, so it's going to cost you less money. You could potentially be pumping as much as 130 gallons per minute through your 2-inch filtration system if you had 2 2-inch suction lines and then they consolidate in front of the pump into 1 2-inch line. You can take that 1 2-inch line and you can push 130 gallons per minute through it, but you are losing a ton of energy to efficiency loss, and that energy is just your dollars. You're losing your dollars to efficiency loss. Design a 24-hour filtration schedule which never exceeds the maximum water amount for laminar flow. If I had a 2-inch plumbing system, I would design a 24-hour schedule for my filtration that never exceeds 65 gallons per minute. And honestly, the amount of time that I'm spent running at 65 would probably be minimal, 4 hours at most. And the rest of the 24-hour day is going to be at various speeds lower than that even. Unless the pool has some sort of feature, like an attached hot tub with booster jets or big waterfalls that need a lot of flow, well then you never really need to exceed these amounts. It's very common to run your pool pump at very high speed and have 80 gallons per minute through an 1.5-inch pipe, or 120 or 130 gallons per minute through a 2-inch pipe. Super common, but it's still a terrible idea, and you don't have to do it. And if you design a better 24-hour schedule with your variable speed pump, you will save a lot of money, and use these numbers as the mark that you're aiming for in terms of how much flow you should have, what your maximums are, and how to understand things like safety in relation to maximum flow rates for the suction lines in your swimming pool. So now that we've kind of gone over these numbers here and you have an idea of some of the soft maximums for your flow rates, or our maximum for most efficient flow rate said another way, let's get over to the pump. Let's run some water through it. Let's look at the power it's consuming. Let's look at what RPM it's going to take to replicate these numbers here. And I tell you what, I bet you the RPM is going to be a lot lower than you think it's going to be. We are isolated on the 2-inch suction line. And let's go ahead and ramp up the pump speed here. The range for this pump is 600 RPM to 3,450 RPM. So at 2,100, like, we're in the middle range here. We're, not really that high, really. There's a lot more to go. But as you can see, already we've hit our maximum here, 65 gallons per minute. And anything that we go in excess of this number is going to be at great efficiency loss. And it's worth noting, even if you have multiple suction lines, if the trunk line of your filtration system is just 2-inch, this is it. This is your soft maximum and your hard maximum for most efficient zone. Okay, top right number is important. That's just 419 watts is what that's reading. 1.79 amps. And that's on the left-hand side. That's the current draw. And 230 volts is the electrical installation that we're using for this pump. That is pretty interesting. Here, let's get some extra information. Noise meter here is 2 feet 7 to 2 feet 8 inches away from this pump. So we're under 65 decibels there, running at this speed. Again, there's a lot more room. We could go a lot higher than this, but if we do, it's going to, cost us so much in efficiency. It's just not a good idea unless there's something on your pool that needs that. Now what I'm going to do is I'm going to go ahead and slowly switch over to the 1.5-inch suction line. Actually, you know what? Before I even do that, I should just verify with you. Look at this. So we've got 65. I'm going to change from the 1.5-inch, or from the 2-inch to the 1.5-inch, and watch what happens to our flow rate here. Leaving all the other plumbing the same. It's got an extra turn in it, but really not very much, like a single extra turn. But we lost 10 gallons per minute of flow for that. And that's what's significant here. If I actually were to switch all my valves over to the 1.5-inch side and the other flow meter that I have, what we'd notice is that we actually don't really lose much more flow, like another gallon or 2 per minute, but we lost 10 by changing the suction line. Pretty significant stuff. Now 56, that would be, we could go as high as 80 or more with this 1.5-inch suction line, but it's not a good idea, and it's certainly not efficient. So now we have 1,500 RPM. And remember, this is a 1.5-inch system that we're looking at here now. This number will fluctuate a little bit. It was 37, or you see 37 again, 38. So this is about 38 gallons per minute. And this is about your maximum for efficient flow if you have a 1.5-inch trunk line for your plumbing system. 175 watts, 176 almost, 0.81 amps on the left-hand side there. That's very, very little. And yet still we're getting, between 37 and 39 gallons per minute. That certainly adds up. By the end of the day, if you just let this run for 24 hours, that's 54,720 gallons of filtered water. So there's not really a lot of reason to run your system higher than this unless you have something that is specifically demanding in your system. The attached hot tub or in-floor cleaning system, something like that. But you wouldn't have 1.5-inch plumbing for that stuff, that's for sure. At this RPM, it's about 51 decibels. I'm a lot more than that. So let's change this back over here. So again, we're at like 38, something like that. I'm gonna go ahead and change it back over to the 2-inch side. Nice and slow. There we go. Again, we'll just note the difference. Up to 43 gallons per minute. And again, this is just from changing the section line over. So it really goes to show you that changing pipe size is very important. I really heavily endorse things like sweep elbows and avoiding street elbow fittings and things like that to reduce on the friction loss in your plumbing system. And I find in general people get a little hung up on that. And a lot of times if you're investing into things like sweep elbows and stuff like that, it would actually be a good conversation to have to see if we can increase the size of the plumbing lines for your filtration system. You would have much more dramatic benefits from increasing the filtration or from increasing the pipe size for your filtration system versus hunting to use sweep elbows versus a short radius 90 or a street elbow. I mean, those things are good, but if at all possible, if you can, it would benefit you greatly to increase the size of your plumbing lines. That's why we get such a profound difference there when we switch over to the 2-inch. Now, one thing I want to do here with this Tristar pump to show you is how much noise it makes. So we're back on the 2-inch system. We'll do a top speed test here that's going to cover both the maximum gallons per minute, maximum power consumption, and then we'll get a noise reading on that, as well as getting a reading off of the filter when we're operating under our maximum speed. So here we go, maximum speed. Make it so. Make it so again. It's flashing at 110, but I've watched this fluctuate between 108 and 110, so I know we're basically just pinging off the upper limit. And I have a manual meter that I double check this with just to make sure. So it is a true number. We're not off scale here. It is in fact 110 gallons per minute. Top right, 1.66 kilowatts. Take note of the decimal point move there. 1,660 watts is how you would read that. 6.99 amps, 7 amps. That's pretty amazing again for the amount of flow that we're getting here. But it's so inefficient. You'd be way better to run 24 hours a day, not exceeding 65 gallons per minute with a 2-inch system or 38 gallons per minute with an 1.5-inch system. And I talked briefly about having an advantage here with these unions on the pump being compatible with 2.5-inch fittings. If you had a 2.5-inch system instead of 1.5 or 2-inch, then instead of 38 or 6 per minute, your maximum number for most efficient flow range would be up to 90 gallons per minute. If you ran that 24 hours a day, is 129,600 gallons of filtered water. And that low and slow method where we're not exceeding the maximum upper limit for laminar flow for the water, minimizing our friction losses, boy, you can get an awful lot of filtered water for not that much money. We're going back to maximum speed, and I'm getting a filter pressure reading. Right around 11 psi. Running at 2100 RPM, we got 65 gallons per minute. It was using 420 watts of power consumption. So that's 10.08 kilowatts consumed over the 24-hour period. At the national average of 13 cents per kilowatt hour, that would be $1.31 per day to run that schedule. Looking at the 1.5-inch system where we were running at 1500 RPM in order to achieve 38 gallons per minute with this pump, 175 watts power consumption, 4.2 kilowatts total consumption at 13 cents per kilowatt hour, 55 cents per day to operate this schedule. And again, with this schedule, you're getting 54,000, almost 55,000 gallons of filtered water a day for the 1.5-inch system, 93,600 gallons of water per day for the 2-inch system like this. And this is just if you ran the pump one speed 24 hours a day. To be clear, it's not ideal to do that. A lot of pool owners end up doing it because they don't really know what else to do. So they just kind of do that and figure it's maybe a happy medium between the pump seems to be working, the pool heater is working, the salt system's making chlorine, like probably this is okay if I just run it. And if the pool doesn't turn green and nothing else terrible happens and all of your equipment is working, then yeah, you could do that. You could get probably better results by dialing in further by having periods of time at higher speed, mid speed, and then long hours at low speed where you're getting perhaps 20 gallons per minute a day. I like something like 4 hours per day towards my upper range. If I had 2-inch plumbing and 65 gallons per minute is the upper range for laminar flow, what I would probably call is like 50, 55, 60. That would be my high speed. I would never, go right for the highest. I don't need it. I don't need to be that high. 8 hours per day, I want to drop that down to 30 or 35 gallons per minute. The remainder of the 24-hour day, I run the pump on such an RPM that I'm going to get 20 or 25 gallons per minute. That's enough for most salt chlorinators to run. That's enough for most gas heaters to run. There's a lot of peripheral equipment that will still be able to run at any time of the 24-hour day with a dynamic schedule like this, but you will be getting the most filtered water for the least amount of money when you optimize like this. One other thing I'd like to mention about the VS900 that is definitely an advantage to pool owners is that this is dual voltage compatible. So whether you have 115 volts or 230 volts as your electrical supply for your pump circuit, this pump is going to work for you. Now, there is a difference in performance and operation between the two voltages. At the lower voltage, it's going to be less high performance pump. It's not going to have the same top end to deliver the power. There's simply not enough current available in a standard 15 amp circuit that you would use for 115 volts. Even at 20 amps, it wouldn't be enough. And that's why whenever you're talking about more powerful pool pumps, kind of anything 1.5 horsepower or larger, typically speaking, it has to be 230 volts for the electrical supply in order for the pump to have that high-end power. This pump is the best of both worlds. If you have the lower voltage available, or you only need that because your swimming pool just doesn't need the high-end capabilities of this pump, well, then you can use the 115 volt application. If you have 230 volts, which really you should for your swimming pool pump these days, especially if you're talking about larger ones, then of course it's going to work and it's going to perform even better. Basically, 3000 RPM is more or less what you're going to have in terms of your top end at 115 volts, and then 3450 is what's available when you have a 230 volt electrical installation for the pump. I've covered a lot of really compelling reasons here today why this pump is my favorite pool pump. From the easy to handle lid to the extraordinarily large strainer basket, the CPVC slip unions that come with the pump, and they have a 2-inch interior fit slip port or 2.5-inch spigot port on the outside. That's fantastic. The keypad rotates 4 directions or remotely mounts or can be compatible with automation. The pump itself moves an impressive amount of water for a very small amount of electricity used. So whether you're looking at a system where you only need the low end power, or you have a more robust plumbing system and you need more performance from this pump, there's a good chance that this pump in specific, the VS900, is going to work for you without being overkill. That's very important. Overkill is not good. It can actually be dangerous on swimming pool systems. And that's why I always stress to pool owners, I'm not really sure you need a 3 horsepower pump when you're talking about filtration application, unless you have something very specific about the pool that requires that amount of power, and the pool has been purpose built for that application. Probably a 3 horsepower is not for you. That's why I love this VS900 at 1.85 horsepower, but it still has a performance chart similar to a high head pump in that it moves a ton of water even at the lower speeds. That's fantastic. But if you have a more robust system and you have a higher resistance to flow, this pump can still perform very well. It's very important to understand every swimming pool is unique. There is no one pump fits all situations, but I like this pump in particular because of the versatility and the features that it offers, the efficiency that it has, and the flow rates that it can achieve. If you found this information helpful, please be sure to like this video and subscribe to my YouTube channel. And you can check out my website, swimmingpoolsteve.com.